This is the third video on section 7.7, triple integrals. And we're following along kind of what we did with double integrals. So remember what we did with double integrals. We looked at Fubini's theorem, and that was nice for integrating over rectangles. But then we looked at the next section and said, guess what? Not every region in R2 is a rectangle. So what do we do with type 1 and type 2 regions? Well, we're going to do something similar here. What we did in the previous videos is we used Fubini's theorem to integrate over rectangular prisms. Well, guess what? Not every region in R3 is a rectangular prism. So what do we do when it's not? Well, we're going to look at three types of regions. And they're similar in flavor to the two types of regions we saw in R2. It's just that now we have three of them because we're in R3. A type 1 region is we have this region in R3 and we project it down onto the XY plane. And so that's what the X, Y, and P is right here. So what's our region? It's a set of points, X, Y, Z, with three coordinates, where the X, Y is in P. P is the projection of that onto the XY plane. So it's the projection of R onto the XY plane. And so every point X, Y, Z that is in this region, the X and Y coordinate, we just make a coordinate of two dimensions, X, Y, that's in P. You can also think of this as the point X, Y, 0, but it's down here on the XY plane. And then Z is stuck between two functions. We have G1 of XY is less than or equal to Z is less than or equal to G2 of XY. So Z is stuck between two functions of X and Y. And so when we integrate over this region right here, what we do is something similar to what we did with the type 1 or type 2 region in R2. We're going to integrate with respect to Z first. And so we integrate from the smaller of the two functions to the larger of the two functions. We have G1xy, G2xy, because G1 and G2 are functions of two variables. Integrate with respect to Z. That means we pretend X and Y are constants. So we find an antiderivative with respect to Z, substitute our upper limit of integration, substitute our lower limit of integration, and subtract. And now, when we do that, we now have a function of two variables, just X and Y. And so now we're integrating over the plane. This is wrong. Let's see, I did that one right. Okay, right here. I'm not going to reshoot the video. I'm just going to change this. Right there. We're integrating over P. So R is the whole region. But here we've already integrated with respect to Z, and now we have this projection. This is an R2. And so we're integrating over this dA. And maybe this is a rectangle and we can use Fubini's theorem, or maybe it's going to be a type 1 or type 2 region itself in R2. And so there's still going to be more work to do. But the idea is now we know how to do a double integral. And so we've reduced it to that case. Type 2 region. Here we have the X stuck between two functions of Y and Z. So we have X, Y, Z right here, where Y and Z are in this projection. This is the projection of R onto the YZ plane. And so X is stuck between two functions of Y and Z. So in this case, we integrate with respect to X first. We integrate from H1YZ to H2YZ. Find an antiderivative with respect to X. We pretend Y and Z are constants. We substitute, subtract, and then we just have a function of Y and Z. So we integrate over that projection, dA. So now this is just a double integral. After we've calculated this first integral, this inside integral with respect to X, what we have here is simply a double integral. And I didn't write out the details for a type 3 region, but what's left? In a type 3 region, now Y is sandwiched between a function of X and Z. So instead of having the Z right here sandwiched between two functions, and here we have the X sandwiched between two functions, for a type 3 region we have the Y sandwiched between two functions. Then we would integrate with respect to Y, and then we would just have a function of two variables X and Z, and our projection P would be in the XZ plane. So you can understand what a type 3 region is just from what type 1 and type 2s are. Also, it is in your notes. So in the type 3 region, I do have the details of what it is written out in the notes, as well as the details of integrating right here.